Academy. Today we'll be looking at ratio part 2, and without much ado, let's begin. Let's quickly look at this tutorial, because this type of questions are very Cambridge is very conversant with this type of questions. They normally give this type of questions in the exam. So let's quickly have a look at this before we solve all the questions.
In this tutorial, we're going to look at how we use ratios. And we can actually use ratios in the sort of obvious ratio type questions, but also for all sorts of other things like currency conversion and so on. So what are we going to do? Well, first of all, we're going to write what we know in ratio form. And sometimes that will take more than one line, and I'll show you that as we go. And then we're going to add any extra bits that we think might be useful, like a total or a difference or a sum, and usually the question will give an indication of that. And then we're going to use scale factors to complete lines, and then, well, we just have to pick out the right answer. So, let's have a go. So we have John, Kevin and Lionel are splitting some money in the ratio of their ages, and we're given their ages here, so that's a ratio, and we're also given the total amount of money, and we're asked how much does each boy get. Well, let's write down all of that information in ratio form. So, John to Kevin to Lionel, well, looking at their ages, that is 7 to 9 to 10. And then looking at money, so this is the second line, well, actually we're given the total amount of money. So we need another thing here, total, and we're told that that is $130. Okay, and what is it we're trying to find? Well, actually we want to find each one of these three things here. Okay, what can we fill in straight away? Well, we can add up the ages to get the total age there. And 7 plus 9 plus 10 is 26. And now we're going to use scale factors. Okay, and the two things that we know in both ages and money are the total. So how do I get from ages to money? How do I get from 26 to 130? Well, as ever with scale factors, we divide the second one by the first one, and 130 over 26 is actually 5, so we're going to use 5 as our scale factor. And so all we do is we multiply each of these things by 5, and that will give us the answers we want. 7 5s are 35, 9 5s are 45, and 10 5s are 50. And so we can say John gets $35, Kevin gets $45, and Lionel, the eldest of the three, gets $50. And we're done. Right, let's have a look at another question. Slightly different, but the same principle. This time we have three girls splitting money in the ratio of their ages, and they are Miranda, Naomi and Ottilie, and they are 12, 14 and 14. So again, let's write down that information in ratio form. So Miranda to Naomi to Ottilie, and again let's write down ages there so we know what we're doing, 12 to 14 to 14. Now what about the rest of the information? Naomi gets £20 more than Miranda, so that's going to need a new line because that's in money. And what are we given? Well, we're given the difference between Naomi and Miranda. So Naomi minus Miranda in money is 20. Okay, and what are we asked for? We're asked for the total amount of money. So I'm again going to have to put another thing in here, and it's that we're after. Okay, so we've got a lot of blanks here, but we may not have to fill them all in. Let's just put the colons in for the ratios and see what we can do. Well, can we fill in anything else? We can actually fill in this one and this one straight away, because we know the difference between Naomi and Miranda's age is 2, 14 minus 12 is 2, and we also know the total of the ages, which is 12 plus 14, which is 40. So we can fill in those two pieces of information, and now it's actually very straightforward, having laid it out clearly, to find the scale factor from 2 to 20, which is 20 over 2, or if you like, 10, and so we can just multiply the 40 by 10 as well, and we can see that the total amount of money is 400, and we haven't had to work out the amount of money that each girl gets. We could do, but we don't need to. Okay, not 200, but 400 pounds money. There we go. So laying things out clearly really helps. I'm going to do one more question, slightly different one, classic age type question. The ratio of Rick's age to Seb's age is 5 to 3, and Seb's age to Tim's age is 4 to 7. And we're asked to find the ratio of Rick to Tim. Okay, well, let's start doing this. So, Rick to Seb to Tim. Well, what do we know? We know that Rick to Seb is 5 to 3, and we know that Seb to Tim is 4 to 7. Now, this is all ages down here, okay, but I do need separate lines because they're not quite as we want them. Now, I'm going to need a third line here, I think. Okay, and the one I know the most about is Seb here. Okay, and what I'm going to do is I'm going to find, as it were, the lowest common multiple of 3 and 4, and rewrite these ratios using that in the middle. So, lowest common multiple of 3 and 4 is 12. How do I know that? Well, actually, I've just multiplied 3 by 4, haven't I? Okay, and I've also multiplied 4 by 3. So there are my two scale factors, and I can now fill in this one and this one using the scale factors I've just worked out. So 4 times 3 is 12, and 7 times 3 is 21, and 5 times 4 is 20, and so the ratio of Rick's age to Tim's age is 20 to 21, and so we write that down in ratio form at the end here. And there is another way of using ratios. As I say, you can use them for currency conversion and all sorts of other things.
Okay, I think the first part we looked at 3 examples. I think these examples are clear enough. We've done the ratio explanation and basic calculations in our part 1 video, so we're going to go past all these ones. We're going to go look at real problems and start solving real problems. Is that okay? So let's take a look at this example if it matches what we want to do, or else we look for more problems. It says the ratio of cabbage leaves eaten by 2 rabbits, Alfred and Bob, is 7 to 5 respectively. It is known that Alfred eats 12 more cabbage leaves than Bob for a particular period of time. Find the total number of cabbage leaves eaten by rabbit and eaten by rabbits, and the number that each rabbit eats individually. Okay, this one we can try, but we have to write this one out. We have 2 rabbits, Alfred and Bob, in the ratio of 7 to 2. So we just do that in the summary form. Alfred and rabbit. Alfred Okay, just a moment. Okay, Alfred and What's the name of the other one? And Bob. Okay, in the ratio of 7 to 5, right? So we put the ratio 7 to 5. In the ratio of 7 to 5. This ratio, is it their age? We have to check. Say, ratio of cabbage leaves eaten by 2 rabbits. After about 7 to 5 respect. Okay, this ratio, cabbage leaf, right? So here we have cabbage leaf. We write cabbage leaf. Cabbage leaf. Okay, I just, even if cabbage is a double B, we just use one. Cabbage leaf, cabbage. Ratio of 7 to 5. Okay, then let's see what else the question is telling us. What more information? Now it is known that Alfred eats 12 more cabbage leaf than Bob for a particular period of time. Alfred eats 12 more. So we go look at Alfred. So Alfred eats 12 more. Eating. So whatever this one eats, the difference we're going to find, okay, or addition. We're going to say addition. Addition, and then total. Addition, and then total. Okay, the total between this and this, the total is 12, right? It's 12. Here we have 12. But Alfred eat more cabbage leaf than Bob. So by how many? By how many does he eat? Okay. So Alfred eat more cabbage leaf than Bob. That means 12 cabbage leaf. Okay. And what is the difference in their ratio? We look at we look at the difference in their ratio. What's the difference in their ratio between Alfred and Bob? So the difference is 2, right? The difference in their ratio is 2. It's 2. Let's take a different color so that we don't mess everything up. The difference is 2. But Alfred eat more. He eat 12 more. So this one eat 12 more cabbage than Bob. Is that okay? He eats 12 more cabbage than Bob, right? So 2 parts equals to 12 cabbage, right? And then 1 part will be what? 1 part will be 6. So we divide like we did previously. So if 2 gives 2 parts, parts of this, the difference between these two gives this 12. So 1 part will be what? 2 parts. We say 2 parts equal to 6. Sorry, equal to 12. 1 part will be equal to 6. Meaning I divide, if I want this, I divide this 12 by 2. I divide the 12 by 2. So I just say 12 by 2. 12 by 2, we get 6. Meaning for 1 part, you eat 6 more. For 1 part of cabbage, you eat 6 more. 1 part of ratio, sorry. 1 part of ratio, Alfred eats 6 more than Bob. But for 2 parts of ratio, then it eats 12 more, right? So we say to find what he eat, the total cabbage leaf that is available, we will multiply 1 part that we just calculated. We multiply 1 part that we just calculated with the 12. Sorry, with the 6. So we had 6, right? The total cabbage is this 12 multiplied by this 6. This 12 multiplied by this 6. The difference between them, because this one eat 12 more than Bob. So if you find the difference, which is 2, the difference in their ratio or in their cabbage, and you divide by that, you get 1 part. So 1 part times 12 will give us the total cabbage leaf that is available. So total cabbage, we will say, will be equal to 12 multiplied by 6. 12 multiplied by 6 equal to 72, right? That gives us 72. So the cabbage leaf that is available is 72. So if 72 is the cabbage leaf that is available, so we can calculate any part eaten by any one of them. So if you want any part eaten by any one of them, you say 7 over 12, okay? Or we already got for 1 unit, 6. So I can multiply here by 6. I can multiply here by 6. Okay? So if I want the number of cabbage eaten by this, because we know the total cabbage, we know the difference between the two, you divide by the 2, you get 6. So you can multiply here by 6, here will be 42. So it means the total cabbage eaten by Alfred is 42, and the total eaten by Bob is 5 times 6, which is 30. 5 times 6, which is 30. Okay, why did you divide by 12 by 2? Why did you do that? Okay, the reason why we did that, why we divide 12 by 2 to get 6 for 1 unit, is that, first of all, you add your total ratio. You sum your total ratio. So 7 plus 5 gives us 12. 7 plus 5 gives us 12. Now, you find the difference between these two. It gives us 2. So if you want for 1 unit, because there are 2 people, if you want for 1 unit, you divide 12 by 2. If you divide 12 by 2, you get 6. That 6 is singularly for 1 unit. So if you want what Alfred eats, you say this 7 ratio times the 6, which is for 1 unit. You get 42. If you want what Bob eats, you say 5 times 6, which is 30. If you add both together, 30 plus 42, you still get 72. Okay, even if you don't follow this way, you still get 72. Okay, so that's that for the question. Let's see what the question asks us to tell. What the question wants us to tell. It says it is known that Alfred eats 12 more cabbage than Bob. You can see 42 minus 30. 42 minus 30 is 12. It's actually 12 more, right? If you come here, you say Alfred eats 12 more. Look at what we did here. Let's change the color. This is 42 and this is 30. So if you subtract, if you say 42 minus 30, you actually get 12. You actually get 12 more. So if you subtract, you see that Alfred actually eats 12 more. So that's what the information the question was giving us. It said Alfred eats 12 more cabbage than Bob for a particular period of time. Find the total number of cabbage leaves eaten by the rabbits and the number that each rabbit eats individually. We found the total. The total is 72. We found the total. The total cabbage is 72. We found the total cabbage eaten by, and the number eaten by each rabbit. Okay, rabbit called Alfred is 42, and rabbit called Bob is 30. So that's all for this question. That's all for this question. Now let's go to another question. Now this time around we're going to bring from another text. Okay. Now let's take question 2. The one we did now, we call it question 1. Now let's see question 2. For question 2, we said Ahmed works in a bank and okay, I think we've looked at this. In 5 sets tennis match, tennis player A hits 120 first serve. 84 of this first serve goes in. So in a 5 set tennis match, 5 sets, in five set tennis match, in 5-set tennis match, player A, I'll just say A, player A hits 120 first serve. Player A hits 120 first serve. 120 first serve. Okay, player A hit 120 first serve. Okay, then 84 of these first serves goes in. 84 goes in for him. 84, so I'll just say 84 goes in. So after serving 120 times, 84 went through for him. '84 goes in. What is the success rate of player A's first serve? What's the success rate of player A's first serve? That's the question. What's the success rate? What is the success rate? What's the success rate of player A's first serve? Of player A, I will just write A. Of player A's first serve. Okay, we use ratio to solve this. We use ratio to solve this type of problem as well. Okay, first of all, as a ratio, we put them as a ratio. So we say ratio, let me change. We say ratio. In ratio, we have 84 that went through, what went through and what you have to serve. That's ratio 84 to ratio 120. What went through for you and the total number of serve you made. So we can reduce this by reducing it to the simplest form. So what number, we can divide 84, right, by 12, right? And we can divide 120 by 12 to reduce it to the lowest term. In doing that, because you must simplify any number to a ratio in the simplest form. So divide this one by 12. 12 is a common factor. Divide here by 12, also divide here by 12. The reason why we are dividing by 12, 12 is the highest common factor, HCF, of these two numbers. 12 is the HCF of these two numbers. So we can easily divide both numbers by the HCF, the highest factor. So 84 divided by 12. Okay, 84 divided by 12. We get what? We get 7, right? We get 7. And 120 divided by 12, we get 10, right? We get 10. So the ratio is actually 7 to 10. The ratio is actually for what you got and what went through and what did it go through. So we can express this also as fraction. If you decide to put this in form of fraction, this will be what? If you want to express it as fraction, this will be either you say 84 over 120, either you write like this, 84 over 120, or you write in the simplest form. You write in the simplest form, which is the simplest form, which is 7 over 10, which is equal to 7 over 10 in terms of in a form of fraction, 7 over 10. Now the question wants us to tell the success rate. Okay, to tell the success rate. So to tell the success rate, you have to put it in percentage. We have to put it in a percentage. to be able to tell the success rate, because when they say rate, success rate, you express in percentage. So success, your success rate will be 7 over 10 times 100 multiplied by 100. And so that we can know how many percentage of success do you have. 7 over 10 multiplied by 100. Multiplied by 100. So we'll be able to tell the success rate of this service, of this serve, table tennis serve that this player made. So this 0 cancels this 0. So we have 7 multiplied by 10, which is 70. So the success rate is 70%. So the success rate of this serve that this table tennis player made is 70%. Is 70%. So we can use ratio to solve all manners of questions. We can use ratios to solve all manners of questions. Now let's look for another question, something a little bit different from this format. And then before we go back to this thing that we were using. Question number 3. Let's say, for example, we say a piece of wood is 150 centimeter long. 150 centimeter long. So I don't have to write all the English statement. A piece of wood is 150 centimeter long. 150 centimeter long. Okay? And it is cut into 2 pieces in the ratio of 2 to 3. So now this wood that is 150 centimeter long is cut into 2 pieces in the ratio of ratio 2 to ratio 3. In the ratio of 2 to 3. This wood is cut into 2 pieces in the ratio. How long is each piece? Okay, I think this one we're already familiar with this type of problem. We're already familiar with this type of problem. So what we do, we sum the ratios, right? This is the ratio. This is the ratio. So one way, there are many ways to solve a ratio problem, okay? There are many techniques people use. So the first one is to sum the ratio. So if you sum there, like when we say sum, I'm talking about the total. I say total ratio. For total ratio, I put 5 here. 2 plus 3 is 5. Now for the length, the length of each one we don't know. The length of each one we don't know, we want to calculate. So I put a box for the length of each one. So the length of this one, for this ratio, we don't know. So I also put a box. But we know the total length. The total length is what? 150. We know the total length to be 150 centimeters. So the first thing we do, we can find a scale factor. How do we find a scale factor? You say 150 divided by 5. Because this is total, this total. Total for length, total for ratio. So you don't say 5 divided, I'm not saying 5 divided by 150. What I'm saying is that 150 divided by 5 so that we can find the scale factor. This is one way of doing it. There are many other ways of doing it. Divide by 5. 150 divided by 5. 50 divided by 5 we get 3. Right? Then 0. That's 30. 150 divided by 5 we get 30. So it means once you do that, you use this as a scale factor. Say 2 multiplied by 30. Because 30 is now your scale factor. You can just simply say this 2 multiplied by 30. You get 60 here for this length. 60 centimeters for this length. And then 3 multiplied by 30. You get 90 centimeters for this length. If you add 60 and 90, you get 150. This is one way of doing it, which is easy. So you get the length of each one. One way is to, first of all, sum the ratio. You get the total sum. Then put the total length. Then you say the total length divided by the total ratio. You get a scale factor. Use the scale factor to multiply each of the ratio. You get each of the length. That's one way. But if you don't like this way, another way to do it, sum the ratio. If you want to find the length of ratio 2, you say 2 over 5. You say this ratio 2 divided by the total ratio, that which is 2 over 5. You put it in fraction. 2 over 5 multiplied by the total length. 2 over 5 multiplied by the length that they've given us, 150. So you know which one is convenient for you or which one you love most. you follow. Okay, you must not follow one way. The one you love most, you follow. The one easiest for you, or the one you'll be used to, you follow. You keep up with it. So 5 goes into 150, you get 30. It's still the same thing. 2 times 30, you get 60. You get 60 centimeter. 2 times 30, you get 60 centimeter. Is that okay? You get 60 centimeter. Then, for ratio 3, you say 3 over 5. You say 3 over 5. Multiply by 150. Please pay attention because these ratios are in paper 4. IGCSE, even the toughest paper, ratio questions are there. In checkpoint, ratios are there. So you do this. 5 divided by 150 divided by 5, you get 30. 30 multiplied by 3, you still get 90. So whichever formula you follow, you're going to get the same thing. Mind you, whichever formula you follow, you're still going to get 60 and 90 centimeter as the length of the 2 corresponding lengths. Is that okay? So whichever way you follow, one is to get a scale factor. To get a scale factor, you know the total length divided by the total ratio. You get a scale factor. Use that scale factor to multiply each individual ratio. You get each of the lengths. Okay? So that's that for this question. We're done with this question. Let's quickly take another question. This question was number 3. Now let's take another question as fast as we can. Question number 4. Question number 4. We say the ratio of numbers of red, white, and blue and green balls are given like this. Red, so I write red, white, so ratio R, red is R, to white, to blue, to green, to blue, to green balls are correspondingly given as 3, 4, 5, 8. 3, they're given to us as 3, 4, 5, 8. So these are the ratios. So we can find, one quick thing we can do is to find the total ratio. So we can put total here, total. What's the total? We sum up these ones. 3 plus 5, 3 plus 4, we get 7. 7 plus 5, we get 12. 12 plus 8, we get 20. So the total ratio is 20. The sum of the ratio is 20. Okay, let's see what the question is going to continue to tell us. A ball is picked from the bag at random. What's the probability a ball is picked from the bag at random? What's the probability that it is red ball? What's the probability that? So you just pick a ball at random. So they're using ratio to calculate probability. They relate ratio to probability. A ball is picked at random. What's the probability that is red ball? So probability that is red ball, this is easy, straightforward. This is very straightforward. Okay, this is very straightforward. Probability that is red ball is the ratio of red over the total ratio. So we can say probability of red. What's the probability that the ball is red? Probability red is equals to the ratio of red over total. Red over sum total. Red over total. Are you with me? So red over total, which is the red balls, the ratio for the red is ratio for the red is 3, and the sum of the ratio is 20. So the probability is 3 over 20. That's your answer. You don't need to do any other thing. 3 over 20. 3 over 20. Okay, my board is lucky. Okay, so 3 over 20. That's it. That's just all you need to do for this type of question. Is that okay? So you can use ratios to solve problems, to solve percentages, and so on and so forth. So I think with this, I think we've done whatever you need to know about ratio, especially the type that we have solved in the tutorial. Okay, if you look at the tutorial, we solved some kind of ratio that will be very helpful to you. Okay, in the tutorial. Okay, let's see if we still have to look at any question. Okay, so I think with the time is limited with us. So with this, we come to the end of this first section. So first of all, we say at the ratio 5. Let's take a look at this. At the ratio 5, 10, and 40 to ratio 28, are they equivalent? So this is a question normally for ratio. So we have what we call equivalent ratio. There are 2 or 3 different ways of finding out if ratios are equivalent. One of it is to put in the fraction and reduce it to simplify the ratio to the lowest term and see if they will have the same lowest term. So if I put this ratio in fraction, this first one will be 5 over 10. And then the second one, let's see, the second one will be 40 over 28. So one way to see if ratios are equivalent is to simplify, see if they will have the same lowest, simplest form of ratio. For example, 5 over 10, if you break it down, 5 divided by 5, you get 1. And 10 divided by 5, you get 2. So the simplest form of this 5 over 10 is 1 all over 2. The simplest form is 1 all over 2. Similarly, if you break this one down, because 40 is half of 28, 40 divided by 40, you get 1. 28 divided by 14, you get 2. So you see, if you break it down, they have the same lowest term. Since they have the same simplest form of ratio, then we say the two ratios are equivalent. This ratio is equivalent to, just a moment, we say this ratio is equivalent to, this ratio. Why? Because when we simplify them to the lowest term, we get the same simplest form. Okay, but that's one way of checking if ratios are equivalent. Another method, we can say this one method 1. Another method, so let's say method 1, M1. Now let's say for method 2, another way of checking if ratios are equivalent is I write 5 over 10, which is the first form of the ratio that was given to us. I say it's equal to 40 over 28. I say equals to 40 over 28. 40 over 28. Another method, I'm showing you another method of solving this problem. 40 over 28. Now, what do you do if they are equivalent? I will cross multiply. The cross multiplication should be equal. For example, 5 multiplied by 28, whatever I get should be equal to 10 multiplied by 40. Another way, these two numbers have to be same. If they are same, then the ratios are equivalent. Okay, so if I say 5 multiplied by 28, what do I get? So we get 140, right? 140. Meaning, if I cross multiply this and this, I get 140. If I also do this, if I also get 140, it means they are equivalent. 40 times 10 or 10 times 40 for the second one. This second cross multiplication. Okay, when you cross multiply 10 times 40, you get also 140. So since you see where both answers, when you cross multiply, they are same, it means the two ratios are equivalent. This is another way, another method of checking if ratios are equivalent. So equivalent ratios can can be sorted out by these two methods. The first method is just to reduce the ratios to the simplest term, and if they are same fraction, if they end up with same fraction, then it means the ratios are equivalent. Or another method of doing that is to cross multiply and get it the same answer, get it the same result. If you do that, then the ratio, we say the two ratios are equivalent. Let's take a look at another ratio we have over here. Let's find out if these two ratios are equivalent. For example, ratio 5 and 30. So you put in a fraction, you write 5 over 30. You write 5 over 30. 5 over 30. We simplify to the simplest form. We use method 1, okay? So 5 divided by 5, we get 1. 30 divided by 5, we get 6. 30 divided by 5, we get 6. Okay, so we get 1 over 6. We get 1 all over 6. This is the simplest form of this ratio. Now, similarly, we do the second one. We try to reduce this if it's possible. Is it possible to reduce this to the simplest form by saying 17 over 120? 17 over 120. 17 is an okay. No number can go into 17, right? Except 17 can only go into itself. So you can see that this is not going to be, because this already is simplest form. 5 cannot go into it. Although 5 can go into 120, 12 can go into 120, 10 can go into 120. None of these numbers can go into 17. So 17 over 120 is the simplest form already. So it means that you see they are not same fraction. So it means this ratio, using method 1, this ratio, they are not equivalent. Not equivalent. Not equivalent. Or like the first one. The first one, they are equivalent. Not equivalent. So this is using method 1. What if we use method 2 to cross-check? What if we use the second method to cross-check what we just said? Okay, using the second method to cross-check. M2. This is method 2. Here is method 1. Okay, here is method 1. Here is method 2. So using method 2 to cross-check, like I said, you write both of them in equivalent form. Say 5 over 30 is equal to, or is equivalent to, 70 over 120. So we cross multiply and see what we're going to get. If we cross multiply 5 times 120, you get 600. If you cross multiply, if you say 5 times 120, I think you will get 600, because 5 times 12 is 60. So this one you get 5 times 120. 5 times 120, you get 600. 5 times 120, you get 600. Then, if you cross multiply this way, 70 times 30, 70 times 30, you get 510. You get 510. You see the two numbers are not same. Since they are not same, 510. Since the two numbers are not same, it means they are not equivalent. It means the ratios are not equivalent. But for the first case, the ratios are equivalent. These are equivalent. Why? Because when you reduce, you get the simplest form of the ratio using method 1. And if you use method 2, you get same number. If you cross multiply, you get same number. So we say equivalent ratio. The two ratios are equivalent for this first one. These ones are equivalent, while the second one is not equivalent ratio. Why this one is not equivalent? Okay, so with this we come to the end of the class.